Where were we? Okay. We are on number 41. Y equals e to the alpha x times sine of beta x. And this is number 41. You're asked to find y double prime. All right, well, first let me just explain that alpha and beta are constants, like A or B or C or D. Normally we just imagine that those are just numbers, they're fixed, we don't know what they are. So try and take this derivative, recognizing that we have a product right here. Okay, it's e to the alpha x times sine beta x. So I'm going to apply the product rule. So the derivative, first derivative, will be the derivative of this times this, plus derivative of this times this. So derivative of e to the alpha x, well, derivative of e to anything is itself, times the derivative of what's up here. So remember, alpha x, taking that derivative, is the same as me saying something like, what's derivative of 4x? You just say 4, here is just alpha. So it's just a constant. So it's going to be alpha here. And then times the second function, sine beta x, plus, so I'm doing product rule here, derivative of sine of beta x. Well, derivative of sine of something is cosine of that something. And then chain rule says go inside and take derivative of beta x, which is kind of like this here. So all we get is beta. And then finishing off the product rule times e to the alpha x. So we have alpha, I'm going to put the constant out front, alpha e to the alpha x sine beta x plus beta e to the alpha x times cosine beta x. All right, so there's my first derivative. Now I can go and take the second derivative right now. And just do each one separately because there's two terms here. Or I could notice that they both have an e to the alpha x and factor it out. Kind of my choice here. I think I'm going to factor out the e to the alpha x. Let me do that. E to the alpha x comes out. That leaves me with an alpha and a sine beta x plus a beta and a cosine beta x. All right, so there's my first derivative. Now let's take the derivative of that. It's going to be ugly. All right, so we have again a product rule right here. Here's my product. Derivative of this times all of this plus the derivative of all of this times this. So y double prime will be the derivative of e to the alpha x, which we did already. E to the alpha x times alpha. So that's derivative of this times all this. Alpha sine beta x plus beta cosine beta x. Okay, plus, now I take derivative of all of this. Two separate terms. So I'm going to do derivative of this one first. Keep in mind alpha is a constant, so it's going to come along for the ride. So constant coming along for the ride. Derivative of sine of beta x is cosine of beta x times beta. Remember, because chain rule, right? Take derivative of sine of something, you get cosine of it. Take derivative of what's inside. Derivative of beta x is just beta. So that's a derivative of the first piece, plus beta is a constant, comes for the ride. And then derivative of cosine of something is negative sine. So I could put negative sine here, but I'm going to just change this to a minus. And then I'm going to have beta x. All right, that's derivative of cosine of something is negative sine of it. And then derivative of inside, derivative of beta x is beta. So I'm done with the derivative of this thing. And then finishing off the product rule times the original first function, which is e to the alpha x. All right, clean it up, clean it up. Y double prime is, let's see here. How shall we do this? Let me distribute this alpha through to both of those. I'm going to leave the e to the alpha x out here. So I have alpha squared, because alpha times alpha is alpha squared, sine beta x, plus now the alpha times the beta is alpha beta cosine of beta x. And that finishes off that. Then over here, let me just kind of put these together. I have an e to the alpha x out front, so I'll put that right here. And then inside here I have alpha times beta, so alpha beta cosine beta x. And then on this one I have minus beta times beta is beta squared, sine of beta x. All right. I'm looking to see if there's anything I can do here. I can collect like terms. All right, this next step is going to look a little weird. I have like two big chunks of stuff. I've got this thing and I've got this thing. They both have e to the alpha x, so I'm going to factor out an e to the alpha x. And then I will have this plus this plus this minus this. So when I take this away and take that out, I'm just left with what was in the parentheses here on both of them. I can put it all together. So I'll have alpha squared sine beta x plus alpha beta cosine beta x. And then over here I have another alpha beta cosine beta x. And then over here I have a minus beta squared sine beta x. And I have some like terms here. These are the same. So that becomes 2 alpha beta cosine beta x. And notice, oh, I forgot my parenthesis here. Notice that this is sine beta x, this is sine beta x. So I could factor a sine beta x out of each of just those two. So I could write this. Plus, let me do it this way. If I just have those two pieces right there, I'll do it up here as scratch work so you can see what I'm doing. I have alpha squared sine beta x minus beta squared sine beta x. So I pull out a sine beta x. That would leave me with alpha squared minus beta squared. And I could rewrite this the other way, which is the way I'm going to do it. I'm going to write this as alpha squared minus beta squared times sine of beta x. Okay, but all of this has an e to the alpha x in front. There you go. Now, I'm curious if that looks like the back of the book. I'm going to check to see if that looks like theirs. This was number 41. Wow. That's almost exactly the way they have it written. That doesn't happen very often. The only thing they have different is they have this here and this one here. But other than that, they're the same. That's a good problem. I like that one. All right, next one, 43, x ln x. Okay. All right, so let's do the first derivative here. They're asking for the second derivative again. So we have to take derivative twice. So the first derivative, we have a product rule right there. So derivative of the first one times the second plus the derivative of natural log of x is 1 over x times the first one. This is just natural log x. That's natural log x plus, this is just 1. And then y double prime is going to be the derivative of this. Derivative of natural log of x, just 1 over x. And derivative of 1 is 0. So that's it. Boy, that was almost too easy. Let's see. This was, yeah, okay. All right, 45. Y equals natural log of x squared minus 3x plus 1. And they give you a point here, 3, 0. And you're asked to find the equation of the tangent line to this curve at the given point. All right, so what we need, of course, to find the equation tangent line is we're going to use this. We already know y1 and x1. We just need to find the slope. The slope comes from getting the derivative at that point 3, 0. So I need the derivative of this. So y prime, we have that the derivative of the natural log of something is 1 over that something times the derivative of what's in here. Derivative of what's in there is 2 terms, so 2x minus 3. So I put it in parentheses, which I could rewrite as 2x minus 3 over x squared minus 3x plus 1. So that's our derivative. We want the derivative at the point 3, 0, so I'm going to replace x with 3 and y with 0. So at 3, 0, we get that y prime equals 2 times 3 minus 3 over, oh yeah, also there's no y in here, so that 0 really doesn't matter. That 0 is only going to come into play right here. Replace that with 3, so 3 squared minus 3 times 3 plus 1. So top is 6 minus 3 is 3 over 9 minus 9 is 0 plus 1, so that's 1, so our slope is 3. So coming back over here to the equation of the tangent line, we know that we get y minus 0 equals the slope 3 times x minus 3. And that means y equals 3x minus 9. So if I graph this line, it should be tangent to this curve at this point. All right, let's look at number 52. Now we're going to shift into a different type of differentiation, very important type of differentiation. Logarithmic differentiation. So number 52, we have y equals e to the negative x cosine squared x over x squared plus x plus 1. Now, if we just tried to attack this right away like this with quotient rule, it would be a mess, all right? So this is where the power of logarithmic differentiation comes in. And what I'm going to be trying to do is use all these properties of logs. Remember, log of x times y is log of x plus log of y, and then natural log of x over y is equal to natural log x minus natural log y, and natural log of x to the n power is n natural log x. So these properties that we had in college algebra, I'm going to try and use those. So what I realized is that I have division, right? I can split division up into 2 logs, right? If I have division inside of a log, but right now I don't even have a log. So logarithmic differentiation, what we're going to do is we're going to take the natural log on both sides of the equation, which we are allowed to do because the natural log function is 1-to-1. All right, now, once we have this, I can rewrite, be careful here, natural log y equals, now over here I'm just going to use properties. I have division, so I split this into 2 logs. It's natural log of the top minus the natural log of the bottom. Then I realized that I have multiplication inside of a log. This log will split into 2 logs. So I have, again, the equation, natural log of y. We want to write it as an equation the whole time. Natural log of e to the negative x plus natural log of cosine squared x. So I've split this log into 2 logs, but I still had the minus natural log of x squared plus x plus 1. And keep in mind, you cannot split this into 3 logs because this is addition. Then, the next step, I'm going to just use some properties here. Natural log and e wipe each other out, right? They're inverses. So they're gone, and you're left with just negative x. And then here, we have natural log of something to the 2nd power. The 2 can drop out. Right? Because remember, cosine squared x is really cosine x squared. And then if I do natural log here, the 2 can pop out in front. All right, so there. And then this minus natural log of x squared, can't do anything here, plus x plus 1. And I think at this point, I'm ready to take a derivative. Now, when we take the derivative using implicit differentiation, using this thing called logarithmic differentiation, we have to use implicit differentiation when we take the derivative. So I have to take derivative of left and right hand side. I'm taking derivative with respect to x. So what is a derivative of natural log of something? Well, it's 1 over that something times the derivative of what's in here. What's derivative of y with respect to x? What's the derivative of y with respect to x? Well, dy dx, but that's y prime. So this is going to be y prime equals, and now I can take derivative of all this stuff. Derivative of negative x with respect to x is negative 1. Plus 2 is attached with multiplication, so plus 2 times the derivative of natural log of something is 1 over that something times the derivative of what was inside, derivative of cosine x is negative sine x. And that's it, I'm done with that. And then minus the derivative of natural log of something is 1 over that something times the derivative of what's inside, which is 2x plus 1. So I have 1 over y times y prime equals negative 1 minus 2. Now check this out. The minus comes from the minus right here comes out. I have sine x over cosine x. That's tangent. So I'm just going to put minus 2 tan x. And then here, I'm just going to slide this on top. So minus 2x plus 1 over x squared plus x plus 1. So I'm getting real close. I need y prime by itself right now. Right now, the left side says 1 over y prime. So I'm going to multiply both sides by y. This whole side by y. And then I'll get y prime equals negative 1 minus 2 tan x minus 2x plus 1 over x squared plus x plus 1, all times y. But what is y? Well, that's y. So I'm going to write that big ugly thing right here. E to the negative x cosine squared x all over x squared plus x plus 1. So I'd have to take that and distribute it through. Boom, boom, boom. But I'm just going to leave it like that. And let me see what the back of the book has. Oh, they don't have the answer for 52, do they? Yeah, I'm sure it's right. Okay, 54. No, 53 is next. Y is the square root of x minus 1 over x squared plus 4. Oh, x to the 4th plus 1. Oops. All right, same thing. I could do chain rule with some quotient rule in there. Let me try this logarithmic differentiation. Take natural log on both sides. And keep in mind that this right here can be rewritten as that to the 1/2. Because the square root of that whole expression means raise the whole expression to the half. Now I'm doing that because I can drop the 1/2 out in front. Now I have the natural log of division, right? X over y. I can split that into 2 logs with subtraction. But remember there's a 1/2 in front. So natural log y equals 1/2 times natural log of the numerator, x minus 1, minus natural log of the denominator, x to the 4th plus 1. All right, and I'm actually going to distribute the 1/2 through. I don't like to have that many parentheses. There we go. So there's my expression. And now I will take the derivative. So implicit differentiation, the derivative on the left side is 1 over y prime. That's going to be the same every time. It's always going to be that. This side, 1/2 is attached. It comes for the ride. Derivative natural log of something is 1 over that something times derivative of what's in there, which is 1. Minus a 1/2, which is attached to the function, so it comes for the ride. Derivative natural log of something is 1 over that something, times derivative of what's inside, which is 4x cubed. That 4x cubed can go on top. So I have 1 over y times y prime equals, check this out, 1 over 2x minus 2. So I actually just multiplied the 2 through the bottom here. I have 1, 1, 1 on top, so that's it. Here, notice this 2 and 4, that becomes a 2. I'll have a minus 2x cubed on top. On the bottom, x to the 4th plus 1. Now I will multiply both sides by y. So I multiply this side by y, and we're going to do that every time. Multiply this side by y. That means multiply this entire side by y. The y's cancel here. The y on this side is actually that up there. So square root of x minus 1 over x to the 4th plus 1. So that's y times all this. All right. Oh yeah. Y is equal to cosine x to the x. Notice that there's a parentheses around the cosine x. So it's the whole thing raised to the x. Now this, I'm sure I mentioned in class, is one of the very unique types of functions that we can get because both your base and your exponent, both of them, right? Both of them. The base and the exponent both have a variable x in them. So it's not an exponential function because this is not a number, and it's not a power function because that's not a number. In other words, like x squared versus 2 to the x, that's a polynomial. This is an exponential, right? Because the 2's are in different places. But if you have x to the x, this is neither one of those because the x's appear in both places. So anytime this is a function of x and that's a function of x, you're going to have to use logarithmic differentiation. So I'm going to do natural log of y on both sides. Then I use the property that I can drop this power out. Don't need the parentheses anymore here. I'll put it. And now at this point we take the derivative. On the left side we get 1 over y prime. On this side we have a product rule. So the derivative of the first one times the second one plus the derivative of the second one times the first one. So derivative of the first one is 1 times the second one plus the derivative of natural log of cosine x is 1 over cosine x times negative sine x, which is the derivative of what's in here, times the first function, x. So that's product rule. This is 1 over y times y prime equals natural log cosine x minus x sine x over cosine x, right? This is minus, so that becomes minus x sine x over cosine. Sine over cosine is tangent. Let me write it that way. Minus x tan x. And then I'm going to multiply both sides by y. So I'll multiply this side by y, it's going to go away, right? Multiply this side by y. Well, what is y? Cosine x to the x. That's what y is. So these are gone. Y prime equals this. We're done. And 62. Find the equation of the line tangent to the curve x e to the y plus y e to the x equals 1 at the point 0, 1. All right, this is an implicit equation in the fact that we cannot solve for y or x easily. So we want to, come up with this formula here, but we need to find m. M is going to be dy dx, or if you'd like, y prime, right? It's that at the point 0, 1. That's what m is. So I need to find y prime. So I've taken derivative of this implicitly on both sides. So what is the derivative of the left side? Well, that's a product rule, and that's a product rule. So let's do a quick product rule here. Derivative of this times this plus derivative of this times this. The derivative of x with respect to x is 1 times the second function plus what's the derivative of e to anything? Itself. Times chain rule, derivative of what's up here, derivative of y is y prime, or dy dx. But then I have to finish off the product rule, so times x. So there's your derivative of the first one times the second one, plus here's the derivative of the second one times the first one. Then we go to the next piece, plus another product rule. Derivative of the first one, derivative of y is y prime, times the second one, plus the derivative of e to the x. Derivative of e to the x is itself. And then you could say times, from the chain rule, times derivative of what's up here, but derivative of x with respect to x is 1. So there's a 1 there, we don't need to write it. But finish off the product rule, you need a y there. And that must equal 0, which is the derivative of the right side. So you can see you have y prime in there, which is good, we need that, and we need it at this point. So at this point in time, I'm going to just replace x with 0 and y with 1. So let x be 0 and y be 1. We get e to the 1 plus e to the 1 times y prime times x, but x is 0, plus y prime times e to the 0 plus e to the 0 times y is 1. That must be 0. So notice on this right here, this term, this whole thing goes away because that's 0 times all that. And e to the 0 is 1. So that's a 1, that's a 1. We have e to the first power over there. So e to the first power is just e. This is just, e to 0 is 1. This is 1 times y prime. That's just going to be y prime. And then e to the 0 is 1. 1 times 1 is 1. So plus 1 equals 0. And if we solve for y prime here, we just take this and this to the other side, they both become negative. That's the slope of your tangent line. It's weird looking, but it's just a number, right? E is a number, so negative E is a number. Take away 1, still a number. Just going to plug that in right there. So the slope of the tangent line, the equation of the tangent line is going to be y minus y1 is 1 equals m, here's your slope, negative E minus 1 times x minus x1, which is 0. So you get y minus 1 equals negative E minus 1, that's this. Distribute that through to x, so times x. Or you could just say that's x, right? That's x times this. It's important that, since this is two terms, you have to put this in parentheses. And then add 1 to both sides. That's a weird looking equation of a tangent line, but it is the equation of the tangent line nonetheless. All right, that's it. 3-3 is done.